Welcome to This Explainer. Today, we are diving into a totally fascinating and, honestly, almost completely silent geological event that crept right up beneath a Portuguese island back in 2022. We usually expect massive volcanic movements to be these incredibly loud, explosive, ground-shaking events, but this one, it completely flew under the radar. It's a massive geological mystery that had researchers all over the globe literally holding their breath. To really wrap our heads around the sheer scale of what we're talking about here, imagine a volume of liquid equivalent to 32,000 Olympic-sized swimming pools. Yeah, that is how much magma surged upward from deep underground, all in just a matter of days. It's an almost incomprehensible amount of molten rock pushing toward the surface. It triggered thousands of sudden earthquakes and kicked off a major scientific scramble, simply because an intrusion of that size, it almost never stays hidden for long. Okay, let's look at exactly what happened. In March of 2022, this hidden, colossal river of molten rock shook São Jorge Island right in Portugal's Azores archipelago. The magma traveled for more than 20 kilometers down, deep beneath the Earth's crust, and shot upward, eventually stalling out just 1.6 kilometers below the surface. It came incredibly close to breaking through. This astonishing event narrowly avoided disaster, resulting in what scientists officially call a failed eruption. Now, hearing the word failed might sound like a bad thing, right? But for the people living on the surface, it is absolutely the best possible outcome. And from a geological perspective, these underground intrusions are actually incredibly important. They're a key process that helps build and reshape volcanic islands over thousands of years, even when the magma never actually sees the light of day. Section 1. A massive stealth magma surge. So how exactly does something this huge just sneak by? How does it move miles beneath the Earth without an immediate explosion or at least a deafening warning? Well, lead author Dr. Stephen Hicks from UCL Earth Sciences called it a stealthy intrusion. The magma moved astonishingly fast through the crust, but with surprisingly little seismic warning during its ascent. It was virtually silent for much of its journey, which, as you can guess, made it incredibly difficult for scientists to figure out if an actual eruption was about to happen. This is wild. What's truly fascinating here is the timeline. You would normally expect all the violent shaking to happen as the magma pushes its way up, right? But the thousands of earthquakes mostly rattled São Jorge Island only after the magma had already stalled out just below the surface. The loudest alarm bells literally only rang once the intruder was already at the front door. Section 2. Tracking the hidden geological threat. Okay, so how do you track something you can't even see? To reconstruct this invisible, totally bizarre magma movement, an international team from the UK, Spain, and Portugal basically had to pull out all the stops. They published their findings recently in the journal Nature Communications. Benefiting from emergency funding, they threw everything they had at the problem. They deployed seismometers not just on land, but way down on the Atlantic seafloor to pinpoint those quakes. And on top of that, they used advanced satellite imagery and GPS data to track how the actual physical surface of the island was reacting to all that pressure from below. And get this, the sheer physical force involved here was just staggering. The satellite and GPS measurements revealed that the entire ground above the volcano actually lifted by 6 centimeters. The immense volume of the magma literally inflated the island. It's just a stark reminder of the massive, hidden pressure moving silently right beneath our feet. Section 3. The highway and the leat. Right, so despite the whole island bulging upward and those thousands of earthquakes, a huge mystery remained. Why did the magma suddenly just stop? Why was the island spared from a devastating eruption? Well, the answer lies in the local geology, specifically a major fault system known as the Pico do Carvão fault zone. Now, earlier studies showed that this specific fault had produced incredibly powerful, massive earthquakes in the past. But this time, it reacted entirely differently. Instead of one huge, devastating quake, the rising magma triggered thousands of tiny, clustered quakes along the fault line. Dr. Pablo J. Gonzalez of the Spanish National Research Council hit the nail on the head here. He pointed out this crazy, yet incredibly fortunate geological paradox. Basically, the very structure that allowed the magma to surge upward so fast is likely the exact same thing that stopped it from exploding. Think of it like this. Mechanically, the fault acted as a highway. It provided this clear structural pathway that guided the molten rock rapidly upward for more than 20 kilometers deep. But at the same exact time, it functioned as a leak. As the magma climbed, the fractured rock of the fault zone allowed all those pent-up gases and fluids to just escape sideways. By bleeding off that explosive pressure laterally, the magma lost all its upward momentum. It simply couldn't burst through that final 1.6 kilometers of crust.
Section 4. Forecasting future volcanic hazards.
So, what does this all mean for us? Well, what happened in the Azores isn't just some localized anomaly. It fundamentally shifts our predictive models for future geological threats worldwide. First off, magma speed. We now know massive surges can happen rapidly, over just a few days, rather than taking weeks or months. Second, the warning signs. The ascent can be nearly silent. The shaking might not even start until the magma is parked right below us. And finally, we learned that major geological faults actively dictate whether magma erupts or gets safely trapped underground.
It also proves that we absolutely have to look at the whole picture. As study co-author Dr. Ricardo Ramalho noted, this incident showed how crucial it is to combine onshore and offshore geophysical data. You can't just look at the land anymore. You have to monitor the seafloor too, if you want to accurately assess these hidden volcanic threats before they ever have a chance to break the surface.
So, knowing what we know now, that a literal stealth surge with a volume of 32,000 swimming pools can silently rise right beneath our feet, and that the loudest warning bells might only ring at the very last second, the ultimate question remains: are we truly ready to detect the world's next silent threat before the surface breaks? Thank you so much for joining me for this explainer. Keep asking questions and never stop exploring the incredible forces that shape our world.